Okay, my last video, we talked about transforming quadratics, and we wrote graphing form of a quadratic, y equals a parentheses x minus h all squared plus k, recognizing that h and k was the vertex. And the question then becomes, well, is there an easy way to get from standard form to graphing form? Now, I could do what I did in the last video, which is figure out the x-intercepts of the standard form, use quadratic formula or factoring. I could use that to figure out the vertex, then I could write it in graphing form, but there's a quicker way, and it is called completing the square. And I will very quickly show you how that works, and then we'll generalize a little bit. So I'm going to start with y equals x squared minus 5x minus 6. And very quickly notice that I could factor this as y equals x minus 6, x plus 1. This gives me x-intercepts of 6 and negative 1, which means that the vertex is at, 2.5. And if I plug 2.5 back into the equation, I get negative 12.25. So the vertex is at 2.5 comma negative 12.25. And that's going to be useful to confirm that what we did is okay. What I want to look at is I want to look at a geometric method. And if I think of x squared as a square, and I take my negative 5x's and I make boxes on either side, and these boxes are of length 1 by x. This box obviously is of side length x by x. And what I get is I get x minus 2.5 and x minus 2.5. If I fill in this corner, I will get a square. Well, when I fill in this corner, 2.5 times 2.5 is 6.25. So I'm just going to add in 6.25 in order to fill that corner. And then I'm going to subtract 6.25 to balance out what I added. I've now added and subtracted the same amount to this diagram. And I had a minus 6 over there, which I just sort of bring down and write off to the side. Well, now I can rewrite this equation. I could write y equals, well, my x squared minus 5x plus my 6.25 comes out to x minus 2.5 all squared. My minus 6.25 minus 6 comes out to minus 12.25. And notice this is a vertex of 2.5 comma negative 12.25, which is what I got when I just factored and found the vertex that way. So let's look at another example with slightly more complicated numbers. Y equals 2x squared plus 8x plus 7. Now notice that I can't make one square because I have two of these x squareds, and there's no way to make one square with two x squareds. So what I'm going to do instead is I'm going to make two squares. Each square gets half of those. Each square gets a total of 4 x's. So remember, these are 1 by x. 4 x's over here. Now, we're not going to have to draw them much longer, but in the meantime, here we go. This is x plus 2. This is x plus 2. And if I fill in this corner here, I'm going to need 4 units to fill that in. And so I'm going to subtract 4 to balance out the 4 that I just added. I'm doing this twice, so I'm filling in this with 4 units, subtracting 4 to balance out the 4 that I added in order to make that into a square. And we'll go ahead and do that. And I'm going to bring my 7 over and just write plus 7 off to the side. There are other strategies where you use the 7 to try to fill in. You recognize that, well, I could have put 4 of those here and 3 of those there. And then I find it a whole lot easier to just ignore the 7 until the end. So what have I got? I've got y equals, well, this is x plus 2 squared minus 4. And over here, I've got another x plus 2 squared minus 4. In other words, I got 2 of those. And I got a plus 7. Doing a little quick simplification, I've got 2 of these squares. I've got 8 that I subtracted for balance. And simplifying one step further, I've got 2 times x plus 2 squared minus 1, which tells me that the vertex of this parabola is at negative 2 comma negative 1, and it has a stretch factor of 2. So that's geometrically. Do I need to do that every single time? Well, no, not really, because what I can do is I can now generalize. I've got ax squared plus bx plus c, standard form of quadratic. I'm going to factor out the stretch factor, giving me x squared plus b over ax. Again, I'm going to leave the plus c off to the side. Now I'm making my squares. How many squares am I making? I'm making a squares. Think back to the previous example. When I have 2x squared, I'm making 2 squares. I'm making a squares. How big are my squares? Well, if we look back at the previous 2 examples, this number right here is always half of what I have available. I had 2 times x plus 4, or excuse me, x squared plus 4x. In the previous example, I had 2.5, half of negative 5. And so this becomes half of b over a. Now, what am I subtracting? Well, I'm subtracting b over 2a squared, because that's how I filled in my square, a times, and I'm bringing down my constant value of c. A little simplification gives me y equals a parentheses x plus b over 2a all squared minus b squared over 4a plus c. And here's a little challenge question for you. If you make y equal to 0 and solve for x, what do you end up with? It's pretty interesting. Very quickly, let's take a look and make sure that this works. On the previous page, I had y equals 2x squared plus 8x plus 7. A is 2, b is 8, c is 7. I should get y equals a, that's 2. X minus 8 over 2 times 2, that's 8, 4, 2 squared, minus b squared, that's 64, over 8 is 8, plus 7 is minus 1. It worked for that example. You can do more examples if you want to double check yourself and see if they come out right. All right. Very simple way to get from standard form to graphing form. And there is the equation that you can jot down in your notes for future use.